Alright, in this video I'm going to show you how to convert some base n number in some other random base, whether it's 5 or 6 or 8 or 12 or whatever, into base 10. So it's like we're taking it out of this alien language and putting it back into English, like the language that we use and the bases and the values that we're used to. So I think the easiest way to do this is to actually expand it out like how we expanded numbers before, and just use like the place values as like a little chart. I think this is the easiest way to do it. So when you see a number like this one, 1, 2, 3, 4, base 5, since it's base 5, that's why I labeled my digits like this. So I put 5 as the base. So 5 to the 0, to the 1, to the 2, to the 3, to the 4, right? Same little pattern that we've had before. Now I only have 4 numbers. It goes 1, 2, 3, 4. So 1, 2, 3, 4. You just write them down in there. If you don't use a digit, then you just don't use a digit. And then what we can do is we can kind of think of this as like a little chart. And we're going to do what we did before. And that is we're going to multiply. We did this when we did the Babylonian numbers. Take the value here times the place value. So digit times place value, digit times place value, digit times place value, and then we're going to add them all together. So what we have is 1 of those 5 cubes, 2 5 squareds, 3 5 to the firsts, and 4 5 to the 0. Now remember, anything to the 0 power, those are always, that's our ones place regardless of what base you're in. Those are always ones. So this is basically 125. That's what 5 cubed is. 2 times 25, that's 50. 3 times 5 is 15. And then you have 4 ones at the end. And if you add all of that together, you get a grand total of 194. So the base 5 way to say 194 is to say 1, 2, 3, 4, base 5. Why does it get more digits? Because remember, in base 5 it rolls over faster. The 4 acts like your 9, and so it rolls over digits faster. So 194. So you just do a chart with the correct bases and then it'll work out. Do the math and it'll turn it into a base 10 number. All right, let's try this one. 515 base 6. Okay, because it's base 6, you can see I wrote 6s here for my bases. Again, your exponents just start at 0 and go on up. Now we only have 3 digits, so I don't need these 2. Create a little chart and like expand it out. So I have 5 6 squareds, I have 1 6 to the first, and I have 5 little ones at the end. So this is going to be 5 times 36. You have to do your exponents first. 5 times 36, that's going to be 180. 1 times 6 is just 6. And then you have 5 at the end. And that's going to be a grand total of 191. So 191, if you want to say it in base 6 language, you would say 515 base 6. So do a chart, work out the math, that'll get you the number in base 10. All right, last one, this is base 12. So I'm doing all my bases with 12s as the base. So you can see my powers are still 0, 1, 2, 3, 4. And this number is ET3. ET3. Well, that's all great, right? The ET3. But I'm about to do math with this. I don't need these digits. What the heck am I going to do with an E, and what the heck am I going to do with a 10? Well, remember what the E stands for. The E stands for 11, and the T stands for 10. We just don't have a symbol, a numeric symbol for that, so we had to go to letters. So they use E and T. All right, so if we do our chart, I'll make this one a little taller. We're doing 11 times 12 squared. So at this point, you just make it normal numbers, like numbers that we're used to. And then we have 10 of the 12 to the first, and then we have 3 ones at the end. So this is going to be 11 times 12 squared. That's 1,584. 10 times 12 is 120, and then 3 ones at the end. And if you add those together, I believe you get 1,707. So that's how you convert some alien base language back into our normal base 10 language. Just do a little chart with the expanded form of the number and you'll have it.